So the next one is air. And the principles of air are that when any portion of air leaves the house, that same amount of air is going to come into the house. The house doesn't live in a vacuum. And what air? When does air rise most? When what? What makes air rise? When you warm it. Same, we're back to the chimney, right? If you warm air up, it rises. The more you warm it up, the more it rises. Why would the Romans have built fires in the towers of their large buildings? In the summertime. Why would the Romans build fires in the top of their buildings in the summertime? It draws hot air up, and it draws cool air in. And so where the air came from is the aquifers. They would run these enormous pipes, these tunnels underground where the water came into Rome. And they pull air from over that. That water, does anyone know what temperature the ground is? Go down 4 or 5 feet? It's about 52 degrees. They were pulling 52-degree air up. It's called air conditioning. One of the most brilliant strategies I've seen for air conditioning is villages in North Africa on the edge of the Sahara. The buildings are built sort of like towers, and they have these boards like this, and the prevailing wind blows across it and creates a suction. And it pulls air from the streets. And all the streets are covered with trellises with vegetation. So the streets are all cool. And it pulls air through the streets and up to the houses. Just natural convection currents. It gets warm, the air blows across the house, creates suction, and it's pulling air up. So it's the natural currents. And one of the things that is important to talk about is to look at the scale from cold to hot. Now, we know we're miserable down here, and we know we're pretty miserable up there. We're not ambiguous about that. Where the confusion takes place is someplace between about 70 degrees or 75 degrees and about 65 degrees. That area in there is what's critical. The amount of heat that we're going to put into the air has a lot of effect on us. One of the characteristics about Americans is that Americans like it cold in the summer and hot in the winter. So we want to wear as little as humanly possible in the wintertime in our house, and we want to be able to wear suits and sport jackets and everything else in the summertime. And so we go into buildings and houses that if in the summer, that if it was winter, people would be demanding the heat be turned up, and vice versa. There is no place else in the world where houses aren't colder in the wintertime and warmer in the summertime. And what we want to do is, and this is particularly disastrous for low-income people because it creates two problems. It creates a problem where people get overheated and then go into the shock of bitter cold, or get over-chilled and go into the shock of heat outside, problem number one. Problem number two, the utility bills are enormous. How many months out of the year in Pennsylvania, Delaware, New Jersey, do you not need any system? You don't need heat, you don't need air conditioning. How many months? Somebody said, what, 3? Anybody say less or more? It was consensus around 3. I'd agree with 3. I'd go with 4, actually. I'd go with 4 because I think it's okay to put sweaters on in the fall and spring when it's chilly. And I think it's okay to be hot in the summertime. And so everybody has a different range. And the irony, of course, is that some people have a reverse range. That is, in the wintertime, they want it hotter than usual. In the summertime, they want it colder than usual. So they not only don't have a gap when they don't need conditioning, they overlap the conditioning in the opposite direction. So they're spending enormous money, yeah.
How much of that reversal is due to the fact that the airflow in the house is so poor that you get these cold spots and the thermometer happens to be in the middle?
A lot, and I will talk about that. And that has to do with air movement and ventilation and everything, yes. What? Right, humidity is a critical factor. That's when we get into moisture. So every one of these things, none of these things can be discussed in isolation. So when we talk about humidity, and we talk about air movement, and we talk about fire, heat, those all interrelate to each other. You can't deal with any of those problems without dealing with all the problems. So I'm sort of going through these and teasing these things out, but they all come together because your comfort level isn't just a function of heat or cold. It's a function of how much humidity and what the temperature is and how much air movement. So sometimes you can be in a room and you can have the exact same temperature and the exact same humidity, but you got the air going by you very quickly. And you're pretty comfortable because it's wicking the moisture away from you. And other times when the air is dead still and the temperature's okay, but you just get claustrophobic because there's no ventilation. Aside from the content of the still air, just the fact that it's still air. So you have three intersecting things. You have fire, water, and air, all profoundly affecting how you are, to what degree you are comfortable. And then you have, of course, the psychology. When it's bitter cold outside, you're really thinking a lot about fear of being cold. So sometimes just out of fear, people will pump the heat up. I go into houses sometimes in the wintertime, and the house is just blazing hot, miserably hot. That has a lot to do with psychology. One of the ironies is, and we'll talk about possessions, is that lower income people, out of fear of discomfort, have a tendency to exaggerate a reaction to the outside temperature more than other people. It has to do with fear. It has to do with insecurity. And so there's this notion of having to do that. Also, the systems don't work. If you are renting a house and you can't open up any windows, what do you have to do to get air movement? You have to turn on your heater or your air conditioner, or else you're in a house with dead air if you can't open up the windows. And so the ability to understand how to move air becomes critical. Now, let's talk about dealing with air within this comfort zone and how we're going to really increase that. What's a way to keep yourself very comfortable on a fairly warm evening or a hot evening without air conditioning or heat when you're in bed at night? Huh? Sleep with nothing on is one way. And a fan is the other way. Those are the two ways. There may be some other ways too, but those are the two main ways. And where would you put a fan? Where would you put a fan that is both healthy and that's effective? Where would be the best place to put a fan? Here I am in this bed right here. There's two kinds of fans. There's a window fan and there's a ceiling fan. Well, there's also an attic fan, but that's really does the same thing as a window fan. What a ceiling fan does, and there's some that are reversible, but basically it's either blowing air right down on me or it's pulling air up, but it's creating some movement of air. But it's only moving the air in the room. It's taking the air in the room and just moving it around. So although there is air movement, there is not real circulation. How would you use a fan? Where would you put a fan? What's the most effective place to put a fan? Which window? I got one in the window already. I have a fan in this window. Is it blowing in or out? It's blowing out, which is then causing What's this principle over here? If any portion of air leaves the house, the same amount must enter. So the fan's blowing out. Where's the air going to come in here? Going to come across this window right here. Now, if I want this to be moving very quickly and I want lots of air, how many other windows do I open up in the house? None. And do I open this window all the way? If I want most velocity, how much do I open the window? You open it up a small amount. Now, if you open it up too small, you're cutting it off. So there's something between this and this that tends to work. Okay? It's a smaller volume. It is concentrating, whereas this fan's blowing a lot of air out. I want this air to come across me in a sheet. So I'm going to close the window so it has about that much of an opening. And I have no other windows, except, of course, if I have another bed someplace, I could open this window a little bit too, and then although I have less volume, I still have air blowing across both places, because no matter where the fan is, as long as the doors are open to the fan, it pulls out. And they used to be able to, and in this house they still have that, they used to be able to, that's why our grandparents understood this, be able to put ventilation through a bedroom and close the bedroom door. How did they do that? How can you do that? The transom, this window right up here, they used to open. They all opened. And so what happens is that you would turn on the attic fan or open up windows and top, and you would have the cool air coming from the bottom, rising up through the house, going through the transoms, through the bedroom, and out the window. You'd have air circulation in the house. You'd have air circulation in the house for 2, 3, 4 months out of the year, particularly in this wondrous climate where we have 4 equal seasons. This is my favorite climate in the world. We get 4 seasons. We get spring and fall and winter and summer. You live in Minnesota, and you have winter and winter and winter, and a little bit of summer and winter and winter and winter, and Florida the opposite. I really like this. But one of the virtues economically is that you have 2 seasons where you do not need to condition the air. It's not necessary. It's expensive. It's ecologically unsound. It's a bad idea. So you maximize the amount of time when you can be warm, without turning on the heat, and cool without turning on the air conditioning, and how air moves through the house. Electric heat is extraordinarily expensive. How can you use electric heat to save money? If electric heat is more expensive than gas or oil, how can you use electric heat to save money? Exactly. You get a little heater and you aim it at yourself, and now you're warm. You're warm. The rest of the house is cold. You zone heat. You put the heater where you are. That's very, very inexpensive, because the option is heating up the whole house. Now, what's one room in this house that I want warmer than the rest of the rooms? These are not difficult questions. Which room do you spend naked in? This isn't a personal question. Most of the time. The bathroom. Most people would like the bathroom warmer. And so what people do is they go to take a bath and they turn the thermostat up, and now they heat the whole house up enough so they can be anywhere in the house naked, which is very, very comfortable, but it's a kind of expensive solution. And so one of the best solutions is the electric oil-filled radiator. Have ever people seen that? It looks like a radiator, but you plug it in. DeLonghi is one of the companies that make it. And you keep this door closed, whether there's people in the bathroom or not. And you put this radiator in the bathroom, and you turn it down to a nice low volume, and you keep this room warm all the time, tolerably warm all the time. And then people don't turn the thermostat up every time they want to use the bathroom. There's a warm place to go. And then you have an electric heater that you carry with you. So if you're going to be in the kitchen, then you put the electric heater in there, and it's aimed at you, and you're comfortable. It's the same notion as turning the stove on and closing the door to be warm in the kitchen. The difference is it's not killing you. But it's very inexpensive. Those little heaters, if you just use them for spot heat where you are very inexpensive. So the movement of air through the house is critical. Now when you look at this house, what is a couple of areas in this house that don't get much air movement? In the basement, there's going to be very little. You're going to have, when you get air leaving the house, you know that there's going to be air coming into the house. And that air coming into the house is going to tend to be under this door. It's going to be tended with cracks in the house, but it's not going to come from here. And what do people use the basement for? What are some of the things people use the basement for? For storage. So now we have things in the basement that don't have air circulation. When we get into water, we'll talk about why that's such a bad idea. The least circulation is in the area where the most storage is. Now the bathroom. Do we want ventilation in the bathroom? Do we want it more than in other rooms? Why do we want ventilation in the bathroom more than in other rooms? Moisture and smell. And we won't go into details about that either. We want this room ventilated. We want air moving through this room, and we want this room ventilated. We want air moving through this room. The kitchen and the bathroom, both have moisture problems. The kitchen has moisture problems, it has grease problems, and it has carbon monoxide problems. Here it's mostly just moisture problems and odor problems. But we want air moving through these rooms. Not a whole lot of air up here, enough. We would like to be able to control this air just like this. We want to be able to turn this fan on and off. So if someone takes a shower, when do you want the fan turned on? As soon as you start taking a shower. When do you want the fan turned off? What? Yeah, 10, 15 minutes after. In other words, you want the fan to continue operating after you've turned the shower off because you want to wick the moisture out of there. And so the ideal thing is to have the fan on a timer. That timer, so you don't have to think, can be attached to either a sensor. When you walk into the room, it turns on, or it can be attached to the light switch. You walk into the room, turn the light switch on, the fan goes on, but you want it so that when you walk out of the room, turn the light switch off, the fan keeps going. Ideally, that's what you want. Now, that adds expense, of course, but that's what works the best. And you definitely don't want a fan to blow air out without making sure there's some way for air to get in, and sometimes that's just cutting the bottom of the door off so you got some air coming in this way. This worked better when they used to have a transom up there because then the breeze wasn't past you, it was above you. So it's better to get the air over the doors because you don't want a draft on you in the bathroom for the most part. So the way that the air moves through this house becomes critical. You do want air circulation in the basement. You do want some air circulation up here. You don't want anything static. You don't want to put this house under a vacuum and pull air through a vent across this space into the house. And why is that? Right, because there's a good chance, first of all, it's a crawl space. If you don't want to spend time someplace licking the surfaces of someplace, then you really don't want the air going through there and spreading out through your house. Now, one of the things they have down here, this is a duct. It's running through that space, and it's blowing into here. And what happens if you got a hole in that duct at this point? You got a vacuum. What's going to happen? Where's it going to get air from? It's going to get air from the crawl space. There's a good chance that there's mice and rats and cockroaches and mold and dust and all kinds of things in this crawl space. If you have a hole in something that sucks, then it'll suck whatever's in that room into it, and this system is designed to distribute it through your whole house. So a family in Michigan was told that they had a lead paint problem, and they had to take all the lead paint off all their doors. So they took all their doors down into the basement, and they put stripper on all their doors, and they sanded the doors right by the hot air system that drew air into the system and distributed through the whole house. They had to move. What they did was they had a house that, by the way, didn't have a lead problem at all. There was no reason. The doors were all fine. The lead wasn't bothering anybody. But they were told that because they had lead, even though it wasn't failing, they needed to get it off the doors. So they took a house that was perfectly safe and turned it into an environmental disaster, because they wound up creating dust and then distributing it through the entire house. So it was everywhere. I mean, they had to basically move out of the house and redo the house. They had to paint it. They had sand surfaces. Wasn't good enough. Couldn't clean it. The contamination levels were so high. So understanding how air moves through this house is critical. Whole house fans are great. These are fans that basically draw air through the entire house, really air the house out. I grew up in Chicago, about a block from Lake Michigan. My grandmother used to air out the house in January when it was snowing out. The house got aired out. And what happened to pillows and blankets? They got stuck outside, and the window got closed on them, and they sort of flapped in the breeze, or we had clotheslines going out the back. So things got aired out. Houses got aired out. Everybody knew that you didn't want a stuffy house. You wanted the house aired out, even if it's just for a short time every day.